Hey, good morning, everybody. How you folks doing today? Happy Thursday. Alrighty. Yeah, I'll leave this here for when we get on break. So hopefully you got your coffee and things were going all right. Hey, Mike's, thank you so much for subscribing. That's so sweet. And you're putting that subscription towards the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. That's so cool. Thanks for coming along with us. All right. Just finished off the pot, which is sad, but now I've got the mug at least, so we'll be okay, I think, the rest of this morning. We'll just, with just the one cup left, it'll be okay. We'll have to pace ourselves, I think, for that, so. All right, so we've talked about arrays and array lists, and we're going to move on to file IO from chapter 15, and then we'll talk about project 0, which is going to use some arrays and files. It'll be a lot of fun, don't worry. Let me fire up NetBeans here. I should have done this earlier, but let's see if we can make NetBeans cooperate here. I did get a fresh restart of my computer, so hopefully it's behave a little bit nicer here this morning. I'll always do a little bit better if I restart first, so it's not as many resources being used by other things. I think we're in pretty good shape. Yeah, see what it thinks. Yeah, well, so this one is amazing because it's the thermal pot. So like it never gets real hot on the bottom. There's no heating element that heats the bottom of the pot. Just as it brews, it goes into this little thermal top. It's like got a spring to open it here, and then it'll just stay nice and warm all morning. It's fantastic. And I can take it off the pot once it's brewed, right? You can do that sort of thing. All right, I thought things would go a little quicker after a fresh restart, but apparently NetBeans has other ideas. We'll see. And I was reconsidering. I've been getting computers the last bunch of years specifically the Surface Book, because I like Microsoft products because I'm a big fanboy, but that have a touch screen so that I can use my stylus here and like draw stuff. But they do also sell like external devices for that sort of thing, where I can get a little pad that I can draw on with a separate kind of stylus. And I wonder if that would be a better option then. So as I start looking at shopping for new computers, because that might be fun. Go that route, I think. I might do that. That's interesting. Maybe I'll do that. Wow, NetBeans is just, it's in a mood today. In a mood. Here, let's check on how things are going here. Yep, so the lab for arrays and array lists was due, going to be due on Tuesday. Let me know if you have any questions for that. Yeah, I've heard the Wacom tablets are pretty nice. Just sorry if I try turning it off and on again. Oh, that was my trick to make it work a little nicer here. So I think I got all your syllabus quizzes in. At the end of today, I'll post a quiz for arrays and files. So I'm not going to do anything out of that array list chapter because, again, we didn't really tackle much of chapter 12 at all. We did all of arrays from chapter 11. So everything in 11's fair game. Chapter 12, I won't bother grabbing any of that for the quiz. And then we're going to do all of files today. So it'll be like 11 and 15. So if that sounds reasonable. So let's plan for that. So we'll do for 11 and 15 combined. Not 12. Okay? And then let me close these with projects. I can use my Surface as a pad connected to a desktop. Really? That might be interesting. I didn't know I could connect it like that. That's kind of cool. Nice. Well, so it's the Surface Book, so not like the what is it, Surface Go or the little small foldable ones. But no, I'll have to check that out. That could be fun. All right, so we had arrays and array lists. So let's start a new project here for files. Let's do some file IO examples. Now, I get in trouble if I name it the wrong thing. It makes it difficult to grab stuff out of the library. So it's a little bit funny for a project name, but it's better, trust me. And then I'm going to make sure I put it in the correct GitHub repository folder. Remember, GitHub repositories are just folders. So we want to make sure we make our projects inside of those folders. So for us, we're going to put it in our 2151. Make sure I get the correct semester here, winter 2022. I probably should just go, get rid of some of those other ones because they're out in the cloud. I don't need them locally here. So winter 2022, CIS 2151, and this is our file IO examples. I think we're good to go here. So we've got a couple things when it comes to files. So a couple built-in methods or built-in classes that know how to do all of this stuff. So there's checking files and getting details about files, or maybe even if they're folders, so directories or files. There is reading files and there's writing files. And then there's different types of files that we're going to look at. So we're going to start off looking at the basic text files, which hopefully should be some quick review. So I'm not going to spend a lot of time there with these basic text files, but want to make sure we're starting off fresh here. So let's write a file first, and then we'll read a file. How about that? Does that sound like a good plan? So remember, when you are creating a file, we've got a lovely sort of chain of things to do it here. So we're going to use a print writer, a buffered writer, and a file writer. It's kind of an ugly mess, but it's not the worst thing in the world, right? We're just going to kind of connect them all together here, and then we have something we can use. So we're going to say, hey, I want a print writer. And then what do we want to call this? This is the one we're going to be using here. So I like something like output file or file to write or something like that. Equals a new print writer. And then what print writer needs here, inside its parentheses, you can give it a new buffered writer. Now, you don't always necessarily need this buffered writer here. Mr. Murrock recommends it, so we're going to go with it. For what we're doing, our purposes, we're probably fine without it. But it's a nice little step in the middle here. And then a buffered writer needs a new file writer. And then finally, file writer, you tell it, hey, what name do we want to make this file? So this is our, how we'll call this, the numbers.txt. All those parentheses. Now, NetBeans has no idea what any of these things are because we haven't imported them yet. So we'll click our little light bulbs here, and it should suggest all these imports, java.io.printWriter, java.io.bufferedWriter, and java.io.filewriter. It should suggest all of them. It still is mad at us, though, because we have an unreported exception of IO exception has to be caught or declared to be thrown. So the easy way, and what you probably did in 1500, is you probably just said, hey, this main method throws an IO exception. That's the lazy way. We're not going to do that. We know better. We can use a try-catch block. Right? So if something might cause an exception, we're going to put it inside of a try block here. And a try block says, hey, I'm going to do something that might cause an exception. If an exception happens, please catch it. And you catch specific exception types. So we can say, hey, I want to catch an IO exception. And I'm going to call it EX or exception or anything you want here, really. Doesn't matter. For our purposes, we're just going to print out that exception. Or, bad thing, and then append in here EX to string. Or I think even just EX works. I don't know. Sure. Or just print the exception. That's probably even easier, right? We'll just print out the exception. If a bad thing happened, we'll print it out and say, okay, bad thing happened. No big deal. If we didn't get an exception, our code keeps working in this try block. Right? Hopefully this is nothing new. We should have seen these, right? I'm pretty sure in 1500. If you didn't, let me know. But we'll cover more specifically exceptions and how we can use them ourselves a little bit more a little later on. But for now, right, this we just put it in a try with a block. All the code inside of here runs. If we hit an exception, the code inside of try stops and jumps right to the catch and then keeps on going. Is that okay so far? All right. So when we're working with files, we always do three things. We open it, we read or write it, and then we close it. So closing is a really important step here. So I like, if I'm remembering here, after I open the file, I'm going to call close right away. And then in between, I'm going to do all of the other things here. That way I don't forget. So you open it, you read, write, and you close when we're working with files. Here, let me back that up a little bit. So if we want to write something to our file here, then we wanted to write some numbers. Why not? How about sure, we'll take our output file, and we can call print line. Right? Print line, which looks just like we've been doing print lines for to the console. Yeah, I want to write some numbers. Definitely. So throw some numbers at me then there in chat, and I'll write them to the file here for you. So we're just going to call print line a couple times. We'll write a couple. All right, 429. All right. Anyone else have any numbers we should write to our file here? That reminds me, I didn't look at how the market's doing this morning. I should look. 137, 137, awesome. Okay, got it. Process man, thank you. I'll throw a 5 in here. Looks like because Mike's been subscribed for 5 months. That's amazing. And that's even like a tier 1 sub. That's not even your Twitch Prime sub, which is a free one. Which is pretty cool. If you do have Amazon Prime, if you hook up your account to Twitch, you get a free subscription every month. And 666, you got it. Okay, so we got a couple there. Got a couple numbers. Now, we're not giving it a full path here. All I'm giving it here is the name of a file. So when this file gets created, it's going to be relative to where we're running this project from. And that's kind of a distinction. So you can give it full paths if you want, or you can just give it a relative path. So if we run this guy, and let's see, hopefully it'll run with no errors. I forget, there was this game show, something probably had something to do with whammies. And the whole thing was this funny little character would go around, and if you landed on a whammy, funny things happen. So everyone would say, no whammies, no whammies. I don't know why that's a memory from my childhood, but that's a thing. All right, so it looks like it ran. So what I want to do, I'm going to go, instead of this project view that we're usually in, if I open that up, it's the project view, I'm going to go to the files view and take a look. It'll show me the actual file here. And nope, looks like it didn't make my file. So I probably have that issue with my plugins. I restarted NetBeans yesterday, or deactivated it, activated it, and it started working. And of course now it's not today, but that's okay. So I'm going to go to Properties. I'm going to go to my compiling setting and uncheck this compile on save because my NB Java C plugin hates me. Now I'm going to hit run. Now it should actually do something. Again, it doesn't. We haven't outputted anything to the screen, so we can't tell. But if I take a look at files here now I have a numbers.txt, and notice it's directly in my file IO examples directory. Because when this thing runs here in my, this one it? No, where'd it go? I thought it showed me here. That's the compiling page. I thought it showed me where it ran. Yeah, this one here. To run my project, it calls Ant. So Ant is a little kind of a wrapper package tool here, and it's running it in this directory right here, file IO examples. So that's why that file gets created in the file IO examples directory. That's where we told it to. Yeah, here's the action is run. There we go. So that's the Ant command that it runs, and it does all this cool stuff because Ant is kind of fun. But I can just double-click numbers.txt, and I should be able to see the contents of it. We see 420.69, 137, 5, 11, 111, and 666. And then we do see we did get a new line here, right? Because I've been using print line. So after 666, it goes down to the next line, waiting to write the next thing here. So I can see the files. I can see the contents of the file here. Cool. So printing is no problem. Now if I wanted to read a file here, let's say, I don't know, we'll just get like the sum here. Maybe we're printing out a receipt here. So again, we're going to do a try block. And inside of here, to read a file, we've got a couple options. So last time I showed people how to use Scanner, and then I felt bad because it didn't actually do the thing that the book told us to do. So I'm going to skip that. We're going to go the book route here. It's not too bad, I promise. So we use a buffered reader. We'll say this is a buffered reader. We'll call this my file reader equals a new buffered reader. And the buffered reader then wants a file reader object. Say, okay, so it needs a file reader object. Sure. So let's say this is my file reader. Or I'm sorry, it needs a new file reader. And the file reader object wants a file object, new file object. And the file object, we have to tell it what's the name of the file. So this was numbers.txt. Okay, and then again, we want to add our imports. If you don't want to add imports one at a time, you can come up here and just do io.star is also an option. Import java.io.star will give you everything in the IO package. Generally, I like to do them one at a time. I don't really know why, but sure. So I just do them one at a time. It's not too big of a deal. And because, you know, NetBeans is doing it for you. I guess it'd be more lazy to just import star, but okay. And now we're getting that same message, unreported exception. This time, though, we have file not found is the exception here. So I'm going to catch a file not found exception. Again, we'll call it like exception. We'll just print out that exception. And it says, oh, I don't know what one of these things is. We got to add an import for that exception too. How fun is that? Okay, so we're going to open the file. Then we're going to close it so we don't forget. FileReader.close. Close. There we go. And in the middle, we're going to go do the things. Oh, goodness. Oh, now we're getting a different unreported exception, IO exception. So turns out, again, it probably doesn't mean a whole lot of things, but IO exception is the parent class here. If you've talked about inheritance, we can just catch IO exception specifically. This one is a general exception. A file not found is a type of IO exception. Don't worry about it too much. We'll get to that if you haven't talked too much about inheritance, but hopefully that rings a bell. Okay, so we open the file, we're going to go read it, and then we close it. So if we know we have a bunch of numbers, I'm going to say, hey, I have a double for sum here. I'm going to start it off at 0. Then I want to go read the file. So to read the file here, we've got a couple options. Okay, the buffered reader, right? That's my file reader. I've got file reader dot read line. I can skip. I can get all the lines. So generally, we're just going to read line one at a time. Okay, but if it's empty, we're going to get something else. So we want to say, hey, I want a string for the line. Right, so we're going to declare a line that we're reading here is my file reader.getLine. And then we want to, because we want to keep on doing this, we want to repeat this process over and over and over. We're going to say while line does not equal null. Is it getLine, right? Nope. File reader.readLine. Sorry, read line, not getLine, readLine. So we're going to read the line into a string called line, and if it's not null, let's keep on doing something. So if the file's empty, the very first read will be null, nothing's going to happen. If it's not empty, we know we're good to go. So and then I'll have a double for the value. Or we'll just take our sum here. We'll just take sum, we'll do plus equals, double dot parse double, double dot parse double, given the line. And then I'm going to reset line. Let's go read the next line. Right? If it's not null, parse it as a double, add it to the sum, get the next one. So we're just going to read every line out here, and we know they're numbers, so they should all be able to fit as doubles, right? Anything in here. If I get something that's text, it's going to crash. But again, that's you know not too concerning right now. Okay. So let's give that a try, and then when we're done, right, we'll close the file, and then we will say the sum of the values in your file is, and we'll spit out the sum. Okay, let's give that a try. And you'll notice the contents of our file here, those numbers, it doesn't keep on adding here. Because the default here, when you use a file writer here, is it is going to overwrite the existing file, if it exists. If it doesn't, it creates a new file. So file writer is actually kind of smart here. In print writer, we're just going to overwrite if there is something there. So we could change the values here, right, if we wanted to. Sure. But every time we rerun this here, if I were to go add some more numbers myself, right, we're not going to get, oops, I'm not going to get any of those values out here. So if I go run it, it's going to replace it with this, right, because that's our default option, is it overwrites. And I go check numbers again, and all that stuff I had changed is gone. So you have to be a little bit careful, right? That it's going to blow things away. Right. The other thing here, we will be able to catch the exception if the file's not found, but we could also be a little smarter about it and just avoid getting that exception. Right. So before we do this file thing here, we can say, hey, I want to make a file. I don't know, we'll just call it the input file. File equals a new file, and in here then we'll say I want numbers.txt. And then if my input file .exists, I can go do all this good stuff here. And if it doesn't exist, right, my else here, can't find that file. Right, so and then instead of using the new file here, we just give it that input file. So it should just show up right in the directory. So if you go to the files view here, instead of the project view, so it won't show in project view, but if you go to file view, it should be there as numbers.txt. Or if you are putting it in the GitHub repository, you should also be able to see it. GitHub will say, hey, there's a thing in the folder here. Remember, all it's going to do is watch for files to show up in that folder. Make sure I'm in the right one here. So CIS 2151. Really got to clean up those old ones there. I'll work on that later. So I see, hey, here's the numbers.txt file. Right, it's showing me here. Does that make sense? That's interesting. I've got a line 6 here, but not here. Huh. I would have thought it was going down a line. Interesting. Yep, so you can do this little sanity check here to make sure if the file exists, you can go read it. It's a better way than trying to catch an exception here for that file not found. So this is always better. Check in code than waiting for an exception. So the reason is, and again, we're kind of getting into the exception weeds, but exceptions should be reserved for exceptional things. Like a bad thing happened that we couldn't handle, let's deal with it. Because exception handling is actually kind of relatively slow in terms of the whole process, right? So if we can just say, hey, here's a quick if block, if check, this is better, okay? And then, we're passing in the file that we created up here, and life is pretty good, okay? So that's for basic text files. Now the trick with text files is you have to know the contents. I mean, really for any files, you have to know what's inside of it to be able to read it. Like in this case, I know it's all doubles. Great, I can go read it out. If I wanted to store other types of information, right, maybe I knew the first line had something that was a name and the second line had something that I knew was a number, so I could read a string, and then the next line I could read and parse as a double. Sure, we could do that sort of thing. So we've got options for how we read and write the files. So it's all up to us to make files that fit whatever format we want here. Yep, so it's good. And okay. Yep. All right, let's see. Let's see what else we want to do out of take a look at some of these examples here. That's all just reading and writing, some basic files, that's fine. Those are all the text files. That's fine. Okay, so we want to write, so these were the text-based files where we can actually see the contents. It's in text. The other option that we have is we can write files that are called binary files. So with binary files, they are files that don't have plain text format. So, and you're probably pretty familiar with them actually. So if I go to repository, show an explorer here, if I were to drop a new like Microsoft Word document into this folder here, let me just right click, let me try a new Word document. We'll call it test. And inside of here, actually, I'm sorry, let me put that inside my file IO examples. There we go. So inside of file IO examples and inside of test here, let's go put some text in it, right? We'll just put some numbers in here, right? Why not? Let's do 10 and 20 and 30 and 40 and 50. Just some easy numbers and close it out. If I were to go look at GitHub, it's going to say, hey, there's a new file here. says, oh, it's a binary file. We can't even see the contents of it. So if you want to, you can try. You can right-click and you can say, hey, I want to open with, and let's choose another app here. Notepad. We'll try and open it here, and it's going to be awful looking. This is a binary file. It's not made to be opened in a text editor. Sometimes you get something out that's actual text, because actual text is stored at some point. But all this other stuff doesn't look like text because it's not saving text values. Right? All this other stuff means something to Microsoft Word that we have no idea what it means. Right? There's a particular format for it, but sure, there's all sorts of weird stuff out here. Why not? So this is a binary file, not made for text editor. And it doesn't play very well with Git either, because Git's made for text-based files. But we can write our own binary files if we want. And they're lots of fun. So we've got ways for writing and ways for reading. Right? They are data output streams or data input streams. Right? So we can write specific types to it. So we use that. So this is for binary type files. We're going to use a data output stream. We'll call my binary output file equals a new data output stream given, and the data output stream needs a new buffered output stream, and the new buffered output stream needs a new file output stream. And that one we're going to call it, how about this is my numbers. Now, bin is a relatively common extension for binary files. .bin to indicate, hey, this is a binary file. Other people like dat. It doesn't matter what we give it. It really could, our computer could care less. And we're not going to double-click these to open with any sort of program. They're only going to work here inside of our Java program, because no one else is going to know what to do with it. We need to catch our IO exception, EX, and then we'll print the exception out. And I got to add a couple more imports here. I guess I should have just done that star, but this is nice. Make sure I get each one properly spelled, I guess. All right, and then we're done. Binary output file.close. Right, so still read, write, open, and close, or open it, read, write, and close it. Always those three things. And now to write data here, what we have specifically now, I get my binary output file, and I have write options. Now, write is specific to what type of data are we writing, and it does matter. So we can write individual bytes, individual integers, we can write characters, we can write a string, we can write a UTF string. It gives us the specific formatting here. So whatever pieces of information we want to write here, let's write some numbers here. So let's write double here, and let's repeat that what we had up here. So we had 5 lines. I'm going to grab 5 of those here. So it's not print lines here, but we'll just copy all that. So I'm going to write the double, write a double, write a double, write a double, and write a double here. Okay? We'll write those same 5 numbers here to the file. Okay, and then we'll close it. So let's give that a run. So I should get a numbers.bin file. When we're done, here's numbers.bin. There we go. But if I try and double click it to open it, it says, hey, it appears it contains binary data. You sure you want to open it with the text editor? We'll say OK. And it can't be opened safely with UTF. Right? It's not a text-based format. You can't open it. Are you sure you want to continue? Yes, let's try it anyway. This, my friends, is our file. Weird. But sure, that's what it is. So this one's not great here. I've got Visual Studio Code installed. And Code has a built-in, I guess it's not even built-in, but it has a Hex Editor plugin you can get. So I'm going to go open with Visual Studio Code here. Just for fun, I just want to show you what's actually stored here is the values in hexadecimal, which is crazy. Let's open it anyway, and let's use the Hex Editor here that we've set up. And so this is showing me every byte here done in hex, which is kind of weird, but it's showing me all of them here. So eventually we can find the numbers we wrote here, 420, 69, if we find the right location, because those are floats. Somewhere in here, I think we'll find that right. Maybe not. No, it's not showing it for us. That's okay. So somewhere in here we would have found it. But I think, so a float or a double should take up 8 bytes. Right? So each one of these hexadecimals is a byte here. So it's 1, 2, 3, 4, 5, 6, 7, 8 bytes here. Then the next set here should be my next value. So what did we say was our next one? 137. So what do we get? 137 here? I think we do somewhere, don't we? 137. Oh, I'm not seeing it. So if we did just a bunch of integers, it'd probably work a little bit nicer here. Let's see. What's our next value? 5. Nope. That's unhappy. That's okay. Let's go just a bunch of integers here. Sorry. Let's change these here. So we'll write int. Let's just do 10. I want to show you how they show up here. 30, 40, 20, 30, 40, and 50. Okay, I'm going to rerun it here. We'll replace the contents with 10, 20, 30, 40, 50. There we go. Now in my hex editor, okay, this is going to be a little prettier here. Let's see. So here we go. Now this 0A byte, remember an integer is 4 bytes. So this whole 4 bytes here, right? This 0A is a 10, represents 10. 1-4 here, in this 4 bytes, represents 20. 1E is 30. 2-8 is 40. And 3-2 is 50. Right, because it's base 16 with hexadecimal. Not all that important, but so this is how many ones, or 16 to the zeros, which is how many ones. This one is how many 16 to the ones, how many 16s. So 3 16s plus 2, right? 16, 32, 48 plus 2 gives me 50. Okay, that was exciting, wasn't it? Let's go back and we'll write our binary output, or our doubles that we had before. Doubles are a little bit funkier, trying to find how they're stored. Sorry, it's a little bit trickier because they also have to store the number of decimal places and the actual decimals, and it gets a little funkier. There's some cool stuff that it does behind the scenes, but it's a little weird. So one more time, let me run this though. So if we have 5 doubles written in binary form or 5 doubles written in text form, okay. The numbers.bin file, if I go to the properties on this, I'll see it is 40 bytes, right? 5 times 8, 5 doubles times 8 bytes each is 40 bytes, right? My numbers.text, which has the same numbers written in it, right? If I go to the properties on this one here, notice is 26 bytes. Because we're storing the characters, which is 2 bytes per character, right, in that text file. So 2 bytes per character, so that's, what is it, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then the new line, so 17, 18, 19, 20, 21, 22. So what did we say? Is it 22 properties? 26 bytes, okay. A little bit off here, sorry. But so sometimes storing things as characters works out. More often than not, a binary file is going to be more efficient for storing your data because storing things as characters takes up a lot of space. Right? If I were to just have like a single double that's really long, remember, because doubles can have a lot of decimal places and they can be pretty large, a single double would still take up just 8 bytes. But if it was like 20 characters long, because I had a bunch of decimal places and things, it's going to be a larger file. So binary files are more efficient for storing things And then we can store all sorts of information that we want, actually rather easily, which is pretty cool. So if we want to read a binary file, similar process here. So we're going to do a try block, and actually we'll make the file, so I'll do a file, this is my binary input file, equals a new file. We want a numbers.bin, right? And then if my binary file input.exists, we're good to go try something here. Yeah, so the same thing. So we're just checking if the file exists here. So if you make a file object with the name of the file, you can check to see if it exists so that you don't rely on that file not found exception happening. Same thing we're going to do here. So if the file exists, then we can go ahead and do our try and catch and see if we can't open this file up. So we're going to make a data input stream. This is my binary input equals a new data input stream. Data input stream. And the data input stream wants a new buffered input stream. And the buffered input stream wants a new file input stream. And the file input stream wants my binary input file, or the name of the file. I prefer using the file object because it gives us a chance to check real quick. We'll add our imports, add our imports, add our imports, and then we're going to catch our file, or IO exception, EX, and we'll just print out that exception. Let's see. Oh, I'm in the wrong. That's the if block. No, if is supposed to go outside the try. This, okay, I had that backwards. So we want to say if it exists, let's go try and open it. If we can open it, great, let's go ahead and close it before we forget. Not close. But with our binary input then, we have these read methods, so you have to tell it what specifically it's reading. Right? So if we want to read a bunch of doubles, right, we can read doubles out, you can read bytes out, you can read floats out, you can read integers out. So you have to know exactly what type of data we're storing here to get these back out. So we can read double here. And again, we want to keep on doing this, right? So we're going to have an int for sum, or I'm sorry, a double for sum equals 0. And then we'll have my binary, but we want to keep on reading as long as it's not null. Or I'm sorry, so with the binary files, we've got a different option here. So before we said, hey, just read strings, and if I get back null, it must be done. Because we're not reading strings out, we're not reading the entire line at a time, we have to check. We're going to say, while my binary input dot available is greater than 0. Oh, goodness, it's greater than 0. And the idea here, this available is saying how many bytes are left to read in this file. Because available will tell me. So available tells you how many bytes are left to read. So when it gets to 0, if it's no longer greater than 0, oh, sorry, I missed the mute button there. It won't work. Right? If it's greater than 0, we have something we can read. So I'm going to read the double, and we'll say we'll take sum plus equals the double, and then we're good to go. When we're done with all of that, we close it out, and we say the sum of the values in the binary file are plus sum. Right, so we can read them all out. Again, we have to know what's inside of it. I know there's a double, I know there's a double, I know there's a double, I know there's a double. If we mix and match, we have to be careful with how we read. It's a little harder to do that sort of loop if it's mix and match. Give that a run, and we get the same sum. Look at that. So we have two different files storing the same kind of information here, which is fun. Right, so it's reading and writing our files, binary files versus text files. And we're actually going to work with the binary type files for our project, because you should have done something with just general text-based files for the first, in 1500, your first course. Right, does that make sense? We okay so far? All right, so let's see if we can make this a little bit more dynamic. We got a couple more minutes before we do for a break. Does that sound okay, or do you want a break now? Up to you folks. We can power through for another example, trying to make this a little bit more dynamic, or we could take a break and come back and do it after. I'm open for either. Is that a poll? I can do that, right? Now or later. I don't think that's going to work. How do I do these? Poll. Oh, there we go. Now, break. Now or later. Look at that. All right. You should see a poll in chat here then, and you can vote if you'd like to break now or break later. Should show up like kind of the top of the little chat window there. And hopefully that works. We'll see. I think it'll work. Polls are fun. So I'll commit what we have here while I'm waiting on you folks to vote. I'm actually going to delete that Word doc too. We don't need the Word doc test. We'll leave the numbers bin file there. All right, so here's file input and output, text and binary types. We'll commit and push that. All right, we got votes for later, 3 votes for later. Nice. All right, so we'll keep on going. So if we want to be a little bit more dynamic here, all right, so let's have some fun. 4 votes for later, no votes for now. All right, folks, you win. Is it the laters have it? How do they do that in the British Parliament? Always really fancy when they do their votes. All right, so we're going to leave all of these ones here. So let's go down and let's make some random numbers here. So random equals a new random equals a new random. And yeah, we'll add our import. This is from java.util.random for some random numbers. And let's make we generate a bunch of random numbers. Let me see. So we'll do a random amount of random values to make this fun. So we'll have an int number of numbers equals random.next int, and then we want to go from like 1 to 100. So remember, 100 is going to give me 0 to 99. So plus 1 here will give me 1 to 100, right? So now I'll have a random number 1 to 100. So we're going to do something so many times here. Okay. So what I can do in my file then, I'm going to make a new file. So let's try here. And I'm just going to go copy paste because this is kind of obnoxious every time. Here. And now we'll call this one here my random.bin. And we're going to catch a IO exception called EX, and we'll print out the exception if a bad thing happens. Generally it doesn't, but just in case. So we're going to make the file, and I'm going to remember to close the file. Close. So the first thing I'm going to write here to my file, here, binary output file, I'm going to write an integer. No, oh, that's an input. No, I want output. Binary output file. There we go. I'm going to write an integer. The first integer I'm going to write is, int, the number of numbers. So the first value I'm going to put in here is how many random numbers am I going to enter. Okay. Then I can do a loop. So I can say for int, I don't know, value 0, value is less than my number of numbers, value plus plus. We're going to generate another random value, and we'll just write it. So I can take my binary output file, and I can write another int, and we'll just write random.nextInt given, I don't know, let's do up to 1,000 plus 1. So we want 1 to 1,000 here. So I'm going to say this is how many files I'm going to write, how many numbers I'm going to write, and then I'll write that many numbers to the file. Then we'll take our binary output file, and we'll write, how about we write a UTF string? And we'll write, that's all, folks. So we're going to do a little bit of mixing and matching here. Nothing super crazy here, but so I'll have an int, some number of int, write all the ints, and then end with a UTF, a string message here. So UTF is generally a little easier to use when we're writing strings than trying to write the chars. This is going to be a little cleaner for us here. Okay, so if we give it a run, it should just make a new random bin file for us with a bunch of stuff in it. And let's go see if we can open it up here. So it's random bin. Let's open with code, just for fun. And yeah, that's fine. We'll open it anyway with our Hex Editor. So sure, there's a bunch of numbers out here. So it looks like there's going to be 88 random numbers, right, from 1 to 1,000. So 88 random numbers, 1 to 1,000, and then I've got a string at the end. So notice they all kind of follow this format here, because most of my numbers, right, I know 1 to 1,000 are not going to be very large. So they all have at least 2 empty bytes here, and then some values. So it's a pretty nice looking format. So I can see all the numbers kind of go up until, looks like here. Now this is probably my characters, right? So all my different characters. And I think then, let's see, I'm not as good at reading characters out. So I think most of these ones in here, it should be, that's all, folks, is somewhere in here, right, with this last little bit here. But somewhere in here was all that. And UTF-8 encoding means that we're using 8 bits per character, right? So the different UTF formats here, when we write UTF, our UTF-8 formatting here means we're just using 1 byte per character, which works out pretty well. So if you're, oh yeah, it's translating here for us. That's all, folks. It does show us that. Look at that. So it tries to see, oh, hey, if they're letters, we'll try it as a letter. It doesn't always know if they're letters or numbers, so it's trying. So 54 is giving me the T, 68 is giving me an H, right? So these are the UTF-8 values here it's showing me, which is kind of fun. So I can see all my UTF characters. That's all, folks. And then the end of file here. Boom. Cool. So we've got it. But now, how do we read it, right? That's the harder part. So let's go do our reader here. Again, we'll pretty much copy this. It should be fine. Now I already have a binary input file, so I'm just going to change the name of it. Well, this was going to be random.bin. If it exists, let's try. Great. Let's keep on going here. So we can end the try with a catch. We want to catch a IO exception. Call it EX, and then we'll print out the exception if a bad thing happens. And then we're done. We'll end that if block. All right. So here's our input stream. When we're done, we're going to close it. Binary input.close. So the first thing we need then is an int for number of numbers to read, or number of numbers. I don't know. Sure. Is going to be my binary input dot, and I want to read an int. Read int. No, I wanted read int. Read int. There we go. Now I can use that value in the loop because I know the first thing I'm reading is telling me how many values I should go read. So I can say, okay, so for int value is 0, value is less than number of numbers, value plus plus. Oh, and we already have a number of numbers. That's right. So how about number of numbers to read? There we go. Make sure our variable names are nice and distinct here, right? Okay, so I want to get that int value. So here's the, I don't know, value in file is my binary input dot read int. Let's go read that integer value out. And now we can do something with it, or, you know, maybe we'll just print it here. And we're not going to do anything super interesting. We could add it to a sum. We could find the largest. We could find the smallest. Anything we wanted, really. We could go find it. We're going to read that many. Then we're going to have a string for the ending message is my binary input dot read UTF. Let's go read a UTF string. And it'll print out that ending message. So notice there's no loop happening here, right? no loop, the file tells me how many values I should read. Right? If we are defining in our file that, hey, let's tell them how many things they are to read, then we can just go read that correct number every time. Then we know, okay, after we've read all of those, the next thing to read was a UTF message. Right? Whatever that format that we've defined is when we're writing the file, we just need to repeat it on the reading side. So now we should get out our bunch of random values, and it's going to be different this time. It probably won't be 88 of them. Again, that's all, folks. Right? Yeah, a little bit less here. So how many do we have this time? Let's see. So we have 52 random values this time, right? Along with a that's all, folks. Right? Or we could even print that out too, right? We could say there are number of numbers to read plus values to read in this file. Right? We could do that. We get our message here, right? We get it defined however we want to do, whatever we want to do with the file. There we go. And this time we have 30 values to read, right? That's all, folks. So if we go look at our file, and this byte here is telling us there's 30. There's only 30 values because it's random each time. Again, random might not be the best example here, and Mr. Murrock will take you through an example of a store system. So if we have a product, right, we can write some number of products out to a file. This is our inventory file, right? We can do it as text or we can do it as binary. So there's advantages, again, with the binary format in that it's going to be more compressed. It's not going to take up as much space. And if we're talking about a store inventory, and you imagine you have thousands and thousands and thousands of products, that, you know, a little bit of savings is going to matter at some point, right? Most of the time, let's say disk is pretty cheap, but essentially, if we can do it like this, it's going to work out a little bit nicer for us than trying to convert everything to text and then change it back from text to the other values and all that sort of thing here. So if we know what our given types are, we can write them nicely. And that's what we're going to do for our lab exercise, or for our project. So I'm open to either idea. We could do a lab if you folks wanted on file input and output, or we could go right to the project. I don't want to try and pile on too much, but I want there to be a practice, but I feel like we had the lab for arrays, and if I add a lab for files and then the project, I feel like that might be too much. But maybe it's just a nice basic practice example. You can kind of do a similar thing to this without being too much trouble. I'm open to either. So think about it for a little bit. Why don't we take a break now? I got to go start another pot of coffee because this mug is almost empty and I'm a little sad. Ooh, I played a game of chess with someone from France. I don't know who they were, from France. And I tried pulling out some of the French that I learned in high school. And I could get merci, and that was about it. Okay, yeah, for sure. We can have a lab for practice. No, of course. So let me take a break, and we'll come back. We'll talk about the lab, just a quick little lab for practicing these inputs and outputs. Again, I'm going to skip the plain text formats because I'm assuming this was already done. If that's a bad assumption, let me know. But this should have already been covered in 1500 for just plain text inputs and outputs. But the binary stuff is new. So we'll do a lab with some binary input and output where we're going to write some values out and go from there. And then our project will combine arrays and this binary format to do some fun stuff. So again, the idea with the labs is, like, I'm happy to mostly walk you through them or kind of lay them out real nice and like, okay, here's the steps, here's what you have to do. You just go fill in some blanks sort of thing, where the project is, if you haven't had me before, talk to some of the folks about what they feel like or seem like. But generally I'll say, here's a task to accomplish, go for it. And it's, they've been described as vague, and that's fair. That is intentional. Right, the part of programming that is an art is solving problems and taking a problem and figuring out how do I break it down into smaller steps to make the computer be able to do this thing, and really kind of envisioning how that solution is built. It's not, hey, someone tells me to write this and write this and write this and write this, and I just have to fill in blanks. That's not the real art of programming. So the projects I give are generally intentionally a little bit open-ended or vague, or so that you've got to go through that process of problem solving and critical thinking, not just, oh, okay, let me find the right Java command and copy paste it in, that sort of thing. So we can go from there. All right, so we put some music back on, and we'll take 10. We'll come back to say at 11:15, and we'll pick it up from there. 11:15 here. All right, folks, see you in a couple minutes. Hey folks, welcome on back. Alright. Oh, we almost ended that track there. It was close. Alright, one of these days I'll learn how to fade those out nicely. Alright, so we're going to talk about a quick lab for file I.O. for a small little bit of practice, and then we'll talk about Project Zero. Again, the goal with the labs is that everyone gets them done. Ideally, you would have been able to get them done before you walk out of the room, but you know, we're not meeting in person, so that format's a little bit funky. But that's generally, you know, I'll try and talk for about half the time and then give you something to practice on for the second half. So we'll try and keep that format the best we can. When we get into this section here, it might get a little fuzzy. I don't think we're going to do a lab every Tuesday and every Thursday. There might just be one for the week. We'll have to see how it's going here. We'll go. I know, sorry. You know, I could put the music on behind the scenes. I've thought of that, but I didn't want it to be too distracting. So, I don't know. My family text group now is everyone's been playing Wordle and texting each other our Wordle accomplishments. So that's been a fun little entertaining thing here. So I'm glad Mr. Wardell put that out. It's a beautiful website too, by the way. He did a really nice job with it. Nice and clean. Especially, you know, no ads or anything. He's not trying to sell you anything. He just put together a fun little thing and put it out in the world. And that's one of the cool things about coding, is you can do that sort of thing. The downside is, though, he didn't protect himself against a bunch of copycats and fraudsters and people trying to sell his app on the app stores, because he didn't want an app. He just wanted a website. So, okay, if you've got music in the background. All right. Yeah, so I know some people like it and some people don't, so it's a little different. So hopefully you can just put some on in the background then for yourself. All right, so let's go look at a quick lab assignment here. And let's do lab 2. And let me give you a GitHub link for this one. This will be lab 2. So this will be due in a week by 10 a.m. My plan is to go over the labs after they're due. So you can, you know, ideally see, you know, if you missed anything on it, just see how that was solved real quick. So that's 10 points of labs for the lab grade category, and I want it in the labs assignment category. That's right. I figured out I could do these assignment categories, and they work out pretty nice. Trying to organize things here. So let's do lab 2, CIS 2151, winter 2022, lab 2. Do this from our Java template. Oop. And our feedback pull requests. There we go. Copy that one. So please submit the feedback pull request URL. Okay, so we're going to do two things. We're going to write a binary file, and then we're going to read a binary file. But we want it to be dynamic. Okay, so we're going to write a program that allows the user to create a shopping list in a loop. Allow them to enter an item and a quantity to keep entering values until they are done. They are done, and read and print the file out. So this is, we're going to save the item and quantities in a binary file. So if it's a string for the name and an int for the quantity, right, we know we're going to have this pair of string init, string init, string init, string init, string init. So in that way, if we know it's a pair, right, we can use essentially as long as we have bytes available. We don't necessarily need to know how many are available beforehand, because instead of just reading a double, we can read a string and then read an int. And then go say, hey, is there more to read? Read a string, read an int. Is there more to read? Because if you read them in pairs, we know we wrote them in pairs, so we can follow that kind of format. We don't necessarily need to say, hey, I know that there are 27 items on my shopping list. Right? Go read the 27 things. Either way could work, and you're welcome to do it either way. So if you want to track them and then add that quantity, you're not going to write them until you're done. So either they're at the end or one at a time as they are entering the values. Right? Either way is perfectly fine, whichever approach you want to take for that lab there. Right? So we create the binary file, and then we're looping, okay, give me items for your shopping list. Name and quantity, name and quantity, name and quantity, name and quantity, until you're done. So some sort of, okay, whenever you're done, hit stop, that sort of thing. Go for it. Cool, and then when we're done, we're going to go read it out. So we can read in pairs as long as bytes are available. We'll read the string and read the quantity. Right? Or if you wrote the number of items in the file, read that and loop that many times, reading the pairs. Right? Either one's perfectly fine. It's probably easier to just keep on reading as long as we have some available. Right? Does that make sense? Okay, so that's what we're going to do for lab 2. That sound okay? Oh, that's right. I got to move these ones into that lab category. Let me edit these real quick. Got to put them in the lab category. This will help just group them up a little bit nicer here in D2L. So, oh, cool. A couple more people got that lab 0 in. Thank you for that. So I think that was about everybody. I think one person was having trouble with it that I got to meet up with still. But other than that, I think everything's going well. Oh, so let me edit this here. We'll put the nice name in here. We got to name all these things nicely. This will be our file IO lab. There we go. Okay, and then let me start up a new assignment here for the project. So again, the project's going to be a little bigger here, a little less, hey, here's the steps you need to take to go do this thing. This is CIS 2151, winter 2022. This is project 0. Right, I think I named it project 0, right? Because we have to raise, the first item is 0. Ha 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 ha. I think I called it 0. Or did I call it 1? Maybe I forgot to do my joke. It's not even really a good joke, but... Did you let me in class here? Yeah, project 0. Perfect. I did call it project 0. So good. So project 0. And we'll pick our Java template. Okay.
Dad,
What'd you make?
Dad, yeah.
Did you eat oatmeal?
Yeah. Dad.
You can have a little bit of cereal then. Yeah, if you ate your oatmeal first. Thank you. All right, we don't need the tests. Our feedback pull requests. Fantastic. And we got our link. Okay, go back to assignments. Let me make a new one here. All right, and here is project 0. So the book takes you through doing that, like a store inventory system. So we're not going to do a store inventory system, but let me do, it's probably about 10 points or so. We'll work on the rubric in just a minute here. But let's get this in first. So this will be in projects. Okay, and so please submit the feedback, pull request, URL. Okay. So we are going to write a program that keeps, that manages a theater seating reservation system. Okay, so the idea is we have a room, right, and with a bunch of seats, and we want to know who's assigned where. And we're going to track this by name because we can do that sort of thing. So we'll have all the different seats, and we're going to assign names to those seats. Okay, so we'll keep a binary file for each room. We have rooms 1 through 3. We'll just 1, 2, and 3. Right? Why not? So we don't need a lot of different rooms. So 3 different rooms here. So room 1 has seats. We'll just say 100 seats. Room 2. Oh, let's do these a little smaller here, because otherwise it'll get a little unwieldy here. So we'll just say 10 seats. Room 2 has 20 seats, and room 3 has, let's say, 15 seats. Allow the guest to attempt to reserve a seat in a given room. I guess those should be theaters, right? Theater. 3 theaters. Theater 1, Theater 2, Theater 3. Okay? So ask them which theater and which seat number. See if that seat number is available. Okay, so we're going to be tracking here. Hey, is this one available? Right, whether or not it's available. Okay, so hey, I want to reserve a seat in Theater 1. I want seat number 3. So we've got to open up the binary file for 1. Got to go find that third seat and see if it's available or not. Right? If it is available, write their name to. We're going to put their name. I don't know, in the file for that seat. Right, so we'll say, okay, so this person, hey, what's your name? We'll reserve this seat for you here because we're fancy. We're going to do this by name here. Okay, and then we want to generate a random confirmation code and a number. We'll just say that's like 10,000 to 100,000. And write the confirmation code in the file as well. So we'll have their name and then this confirmation code. So when you show up at the theater, you say, hey, here's my name, here's my confirmation code, and we can then verify, yeah, okay, you actually belong in the seat here because you have the right code. Not the best system in the world, but we're just pretending here, okay? This way we're going to have strings, and then we're going to have numbers in this file here for each theater, for each number of seats. Okay? So, and then we'll allow or add an option for a manager to print a theater reservation list, which shows which seat numbers are taken, the guest name, and the confirmation code for each guest. Reservation. We want to be sure to show empty seats as empty with no code. Right, so if a seat's empty, there's no name and there's no code here. Okay, that sound okay? So we'll have, hey, you can reserve seats. Which theater? Which seat? If that seat's not available, if the seat is already taken, let them know they can't have that seat. Right, so then, okay, you can't have that seat, do you want to try again? Right, that sort of thing. Should we do these as different movies? Would that be more fun instead of 1, 2, and 3? Like, what are 3 fun movies out? We should do that. So this is just for a single showing here. So what's a fun movie that's out? So just shout us a movie, and we'll replace Theater 1, 2, and 3 with this shows this movie, this shows this movie, and this shows this movie. Is there anything fun worth seeing? I heard the new Spider-Man movie was good. Are they still showing that, or like are things only out in theaters for like a week now or something? Some sort of nonsense. Harry Potter, is that in theaters? Oh, really? I thought that was just like an online special. Oh, the Harry Potter theater, awesome. I've been meaning to check that one out. That was like their 20-year reunion, right? 15 year, 20? No, 20 years. How old am I? Man. So a fun fact about Harry Potter: my mother was on a business trip for her company in England because they're an international company. So she was out visiting their offices in England, and she heard someone talking about a really popular book called Harry Potter and the Philosopher's Stone, which was released in England first. Okay, 10 years, good. Okay. Oh, his Friends was like the 20-year reunion, right? That's what I was thinking of. Yeah. Oh, and Encanto, that was amazing. My kids love this one. Encanto was really good. Oh, and I heard recently the CDC announced that it is okay to talk a little bit about Bruno. I hear that's the latest guidelines here about Bruno. Yeah, I don't think she gets invited to many things anymore. She's some of her opinions made her rather unpopular in certain circles. So, all right, so you can watch Harry Potter, you can watch Encanto, or what's the other one? What else is popular? Here, or Harry Potter has 10 seats, theater, or Encanto has 20 seats, and yeah, they always do a nice job with their music. They definitely do. Is the Matrix, is that new Matrix movie out in theaters, or is that just an online release only too? We'll just say Matrix, because why not? Or Matrix, it was like Reloaded, Revisited, I forget what it was here. I've been meaning to watch that one, so one of these days I'll go watch it here. It's terrible. Resurrections, oh no. So I remember I loved the first Matrix movie. 2 and 3 were kind of disappointments. But I loved the first one, so I wanted to go see this one. Re-throw it away. Oh no. Maybe we'll pretend this is the original, right? I mean, or unless you're opposed to the original too, Mike. We'll call that good. So we can have two options then. So the program has two options, right? So the program has two options: guest reservations or manager report. Right. So if you pick guest reservations, let them pick the seat, or pick manager report. Right. And they can print out which seats and which codes. So print a theater reservation list. So we need to ask which theater, right? Which shows which seats are taken. So we can do it one at a time. The rematrixing. Ask which theater, which seat number, see if the seat number is available. If it is, give them that, give them a confirmation code. And then be sure to tell the guest the code as well. And allow them to pick another. Okay? That makes sense? So a little bit more vague and open-ended here, but I don't think anything that you won't be able to tackle. Right? And your life is going to be easier if you do this with arrays. Right? Reading this stuff into an array. Because, hey, I need an array of so many seats. That sort of thing. It's probably possible to do without arrays, but I think you'll just have a better time of it if you use an array list. Or even a basic array. Yep. It's about how there shouldn't be a fourth. Okay. That's a little meta, but it's kind of fun. All right, and we'll do our text submission here. So we need a rubric, okay? So the weird thing about rubrics is it like hides this screen from me. So I'm going to copy all this over to Notepad, paste it back in. Actually, let me save it here, and I'll come back and do the rubric. So save it, and then I'll re-edit it again here. Okay, we'll come back. Oh, I didn't put it in the right category either. My goodness, that's not a lab. All right, that's right. I forgot to change it here. So this is a new category. We will call projects. There. Okay. And then we'll add a rubric. Did I paste that in? I think I pasted it in. Yeah, I did. Okay, good. So if they add a rubric, we'll make a new rubric here. This is for project 0. So the way my rubrics work, either the feature works and you get the points, or it doesn't work and you don't get the points. So if this thing is missing, there's no points. If it's complete, there's points. I do try and do partial points. So like if it sort of works, then maybe you can get 1 point or whatever the partial works out to be in here. Okay. So this will be separate binary file for each theater. So if you just get 3 binary files, you get 2 points. They don't even really have to work to get those points. Just that as long as you have them here, you get the points. So the binary file then contains the seats with guest name and confirmation code. Code if reserved, or blank if it is available. Okay. So then guests can reserve a seat in a theater if the seat is taken, and allow them to pick another. Right? So again, binary files that we're storing information in the binary files. So just like having the files correctly here is worth some points. And then whether or not the guests can reserve their seats is more points here. And then we want to, what do we need in here? Generate the confirmation code, save it to the file with the guest name, seat, and display the code for the user. Right, and then the manager reservation list displays for a given theater. Okay, that should be the 10 points there. So manager list, that's just, hey, just dump everything out of the file, right? Overall score, that sort of thing. So if you follow along with the books example where they keep that product list as a file, they go and make a product class. I would recommend that. You should have done enough with classes that works for you. But if you don't want to, that's okay. It is not required. So I'm not saying it has to be done one way or the other. Just as long as you have binary files, you've got the name and confirmation code, or they're blank. If guests can reserve seats, and if it's taken, allow them to pick another one. Generate the confirmation code and make sure that gets saved to the file with the guest's name. I mean, like we're sort of doubling down here, but like that it works. I don't know. I hope that's okay. And then the manager reservation system. All right, I'm feeling bad now. Should it not be? It shouldn't be this many, right? Let's see. So we'll just, let's just take this one out. We'll just make it 8 points. How about that? So 2 points for the binary files, 2 points for being able to reserve a seat, 2 points for writing the confirmation code and the name to the file, and then 2 more points for that. It'll just be 8 total. 8's okay. All right, I like that. That makes me happy. Does that make sense? So we'll do 8 total points here for this project. And again, the points only matter in the projects category. Okay, so within the projects in the grades there, that's where those points matter. So just because a lab is worth 10 doesn't mean it's worth more than the project, because projects are a bigger chunk of your overall score. Right? It's this weighted category thing. And then hopefully that makes sense. So let me actually, I can delete these other ones. I had them out here so it would like format things nicely and pre-populate, but I ended up not doing those. So just get rid of those ones. All right, any other questions, thoughts, or concerns? Sorry, it took a little longer than I thought to go through and describe all of that. So we were a little shorter on time for finishing up that lab exercise. Gives about 10 minutes left or so, right, to work on that lab exercise. Delete that one too. All right, so next week, I promise we'll reserve a little more time to finish up those labs. Okay? That sound good? Any other thoughts, questions, concerns? We ready to get working? All right, awesome. So if you have any questions, shoot me a message. You've got my contact info, and we can go from there. All right, folks, I'll export this out to YouTube. Don't forget all the lecture archive. I'm linking out here in D2L, or you can go find it on my YouTube channel if you just want to subscribe there as well. Take your pick, whatever works best for you. All right, yep, have a good weekend. Let me know how I can help. I'm happy to jump on and help you folks get pointed in the right direction. For labs, I'll work with you. That's the kind of thing we would have done in class. For the projects, I'll for sure get you pointed in the right direction, but I'm probably not going to like tell you what code to type. So hopefully that works out okay. All right, folks, take care. Keep in touch.